one of the company names I heard a lot this week was NVIDIA. And I think I heard it more than the FDA. I think I heard the name more than I did Medtronic or any of the big OEMs. It's a company with a powerful influence on our industry, and it's really, I think, picking some winners in surgical robotics and other space, or helping them become winners. So I'd like to call up Prerna Dogra. She's a technologist and a product leader at NVIDIA, working at the intersection of robotics, sensing, and embodied AI in healthcare. And she'll explore what it means to move from sensing to embodiment in medical technology. Prerna?
Thank you, Tom. Good evening, everyone. Thank you, Nera and the team, for putting together such a wonderful lineup and this amazing event. I'm a technologist at heart, and so for me, it has to start with the curve that brought us here. Healthcare is shaped by physics, right? More than a century ago, it started with X-ray, and these imaging modalities like ultrasound and CT gave medicine its first superpower: the ability to see inside the human body without opening it. Then came to image reconstruction that gave these signals life and turned them into interpretable images. That's where accelerated computing and GPUs began their journey. Real-time IGT and interventions allowed imaging to move from diagnostics to being part of the procedure, assisting the clinicians in those decision-making. And then we had the big bang of deep learning, right? And radiology led the way, and God, we know we needed that. We've heard about it, we all acknowledge it, the burnout of radiologists. And if any of you were at RSNA this year, right, what amazed me was that every big OEM, every device company, AI was ubiquitous. Then came ambient AI, and it moved beyond the scanner. Now AI is in your room, it can monitor, it can listen, it can take notes for you. And with language models and generative AI, all this foundation gave AI its agencies. Now it could recommend. Now it could interact with you in a language you understand. I believe we are now at the inflection point of the next horizon, physical AI, where AI will be able to see, it'll be able to recommend, but it will be able to act. And the reason is that 70% of clinical care is in action, right? In the procedure rooms, in transporting medication, equipment, transporting patients. And we'll see this AI come in action in different embodiments. Medical devices, surgical robotics, of course, but clinical cobots, care companions, as we heard today, supply chain cobots, and potentially humanoids one day. This, we believe, is the next horizon of AI. And so if physical AI is the next horizon, what is it that the innovators in this room should be thinking about? What is it that we should be solving foundationally from a technology platform standpoint? And it's really the data gap. And just to put it in perspective, ChatGPT was trained on 1.2 billion hours of data. I mean, LLM researchers are spoiled. They're talking about trillions of tokens, billions of hours. They're talking about data exhaustion and the fact that we've run out of the internet. Roboticists, on the other end, start with day one of data scarcity. The way you collect data for robotic training is human fuel. You have a human being teleoping and telling this robot how to do the actions. And so robotics really forces us to start thinking about the scaling laws of data. And there are three. The first one is pre-training. This is take all of the internet and show the robot the world. What is the world you need to operate in? This is how their perception systems are getting trained. Post-training allows you to bring the human in the loop, whether it's reinforcement learning, teleops, but what is that one specific skill? The skill I need my bot to get right. But it's the third scaling law that I'm most excited about, and that's an absolute game changer. The test time scaling and the long thinking. This is where the robot goes into a digital world, a simulation, which is physics accurate, and practices the skill. And the beauty is that simulation is inexpensive. You could have tens of thousands of instantiations. You could be trying all sorts of mistakes, and it's not running on wall clock time. And so we think, and we are constantly asking ourselves, what are the hardest challenges we want to apply our platform to? And this is at the heart of what NVIDIA does. Like, gaming was the first fundamental simulation challenge. And so we've invested in these platforms over a decade now, right? What you're seeing on the left-hand side is Omniverse. This is NVIDIA's platform for creating digital virtual worlds. These are not pixels. These are physically grounded, physics-accurate worlds. They follow the laws of physics. They follow gravity, lighting, texture, collisions. And on the right-hand side, very quietly, early in 2025, there was the introduction of Cosmos, the world models, that are bounded by the physics of Omniverse, but can generate new states. So we're all aware of LLMs and generative AI in language. We're entering the era of generative physics. And so we asked ourselves, what would happen if we applied these platforms to the hardest test of physical AI, surgical robotics? And the results have been promising. I'd like to share some. I mean, on the left-hand side, you're seeing segmentation masks, depth masks coming in, right? And again, you don't want to be in a world of random synthetic data generation. Your synthetic data has to be in a controlled environment. It has to be bounded by the laws of that world, and in our world, that's the laws of physiology. On the right-hand side, and I think this is the right audience for the gory alert, but that's not a laparoscopic surgery. That's generative AI. That was post-trained, that's Cosmos, that was post-trained with a very small amount of surgical data to show it what that world looks like, and then ground it in some of that physically accurate laws of that world to create this. You could prompt it. I am no surgeon, but it does look like to me that that robotic forceps is puncturing a needle into soft tissue. This is phenomenal. I looked at this, and this might just be our transformer moment for physical AI. And everything I shared today, I mean, I applied it to surgical robotics, but it applies across the entire continuum of healthcare, to the cobots, to these humanoids. You're going to have to train them in these digital worlds where they learn how to maneuver their ways in these human-defined spaces. It's very dynamic. How do we interact with humans? How do we interact with each other? And then there's the world inside of the human body, the human physiology. And building world models for physiology opens a huge new opportunities. Everything from patient-specific device and procedure planning to oncology planning. I absolutely believe this is the foundation that will take us one day to the era of abundance in healthcare. And that's why NVIDIA is investing in building the 3-computer architecture to power this, right? So you have the AI training computer, and I hope all the innovators in the room are well familiar with it, they're using it, and you're bringing your data and you're training your models. But the world models I showed you, you're potentially augmenting those models with corner cases that you don't have real-world data for. And you are generating that in a very controlled synthetic environment. You are training these skills, and if it's robotics, you are taking those robots back into simulation to practice. And you practice till your evaluation benchmarks start looking really good, and then you get into runtime deployment. This is the foundation of our mission and how we want to be powering the innovators in the ecosystem. Finally, if you haven't already, please come join us for GTC, March 16th to 19th. We'll be talking everything from physical AI to generative AI to agentic AI, and would love to talk to all of you. Thank you all.